Alright, so in this last video, I want to discuss what happens if we apply too much stress to a solid. So far we've been working in this section here that is proportional. So whenever you apply a certain amount of stress, a proportional amount of strain appears based upon the proportionality constants, which are our moduluses. Now if we continue to apply stress, we enter a region where if you remove the stress, the strain will go back to zero. But we're no longer in a region where the stress and strain are proportional to each other. So in this region here, it's still reversible, but the equations that we learned in class would no longer apply because it's not proportional anymore. So you would need a different relationship in order to solve those particular problems. Then we get into a region where we pass what we call the elastic limit. And once you pass the elastic limit, the deformation becomes irreversible. So this line here is indicating something we call permanent set. Permanent set means that when you remove the stress, the strain goes here rather than the back here to zero. So you're still going to see a certain amount of deformation, because remember, strain characterizes how much deformation you have. So even if you remove the stress, the strain is still not going to go to zero. You're still going to have deformation. And then there's this final point out here we call the fracture point. So this is when you apply what we refer to as the breaking stress. That's the maximum amount of stress that you can apply before the object actually breaks. And so in your textbook there's listed a few breaking stresses for different types of material.